Good afternoon. Today we are doing CO11. We are almost done with Unit 2. We have one more objective after this that we will be doing on Monday. And then we have practice test Tuesday, real test Wednesday. So we are almost done with Unit 2. It's another short unit, so it's going quick. So you need to make sure you are understanding all these objectives. Today, CO11, I can simplify expressions by squaring and using square roots. So when we talked about PERMDAS, squaring is an exponent. The square root, what is the opposite of squaring? Who remembers what we said when we talked, what mathy word did I use for PERMDAS? Emerson? Radicals. The R in PERMDAS is a radical. The opposite of squaring is finding the square root. Lucas?
The square root is the number that number times itself.
So that's what we do when we square.
Well, yeah, that number times that number times itself will equal the number.
Yeah. So because they're opposites, 3 times 2 equals 6, 6 divided by 2 equals 3. Multiplying and dividing are opposites. Squaring and square roots are opposite. So when we look at this, the E and the R that we talked about, complete the tables below to help you remember perfect squares. Perfect squares, I'm going to give you a clue. A little secret about your teacher. They're my favorite numbers. I love perfect squares. Love them. We're going to review perfect squares. Remember, when we square a number, we multiply it by itself. So when we have, they didn't put it on there. When we have that square, that's an exponent. So let's put it right here. 1 squared is the same as saying 1 times 1, because that exponent tells me how many times I'm going to multiply that number. So 1 squared is 1 times 1, which is 1. So you're going to want to fill in your exponents as I'm filling them in. 2 squared would be 2 times 2, so that is 4. What is 3 squared? Somebody say it out loud. 4 squared.
16.
5 squared. 6 squared. 7 squared. 8 squared. 9 squared. 10 squared. 11 squared. 12 squared. 13 squared.
169.
14 squared.
196.
That's impressive. I had to look down and think about that one. 15 squared. 225. And 16 squared. Oh. No.
No. 2 something or other.
It is 2 something or another.
245.
No.
236.
256. You guys were close. 256. We will see perfect squares a lot in math. We'll see it in patterns when we do math packets. We always have that pattern page, figure 1, figure 2, figure 3, figure 4, complete the table. You will see perfect squares popping up all over the place. Learn your perfect squares, know them, love them. They will help you with your math. Do I normally go all the way up to 16 with my perfect squares? No. I do know up to 15. The 14 I had to think about. But it is good to know those perfect squares up to 15, to have those memorized, because you will see them a lot. So our next part, so we have exponents. Our opposite is our square roots, the radicals. So the square root of 1, what times itself equals 1. 1 times 1 is 1. So square root of 1 is 1. So should I put a square root of 2 here?
No.
Why not?
1 times 2.
Because when we're working backwards, we're not finding the square root of the top row, we're finding the square root of that bottom row. So here we said 1 squared is 1, 2 squared is 4. So we want to find that square root of 4 is going to equal 2. So this one we're going to say square root of 9 equals 3. Square root of 16 is 4. The square root of 25 is 5. Square root of 36 is 6. Guys, shh. If I go faster, you can always finish filling it in by watching the video. All I'm doing is going backwards. I'm taking the bottom number, finding the square root, and it's the top number that I had squared. So I am just filling in. Square root of 49 would be 7, because 7 times 7 is 49. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. Square root of 144 is 12. Square root of 169 is 13. Square root of 196 is 14. Square root of 225 is 15. Square root of 256 is 16. They are opposites.
Oh,
Okay. So let's go up from 1. 2 squared equals 4, so square root of 4 is 2. Because we know 2 times 2 equals 4. So we just worked backwards. Now, this lesson, we are working with whole numbers, perfect squares, which give us the perfect square root. Does that mean that we can't do the square root of 10?
No.
On today's assignment, we're not going to do the square root of 10 because our answer is not going to be our whole number. So for perfect squares and those perfect square roots, we have the whole numbers. We're going to find out on Monday how we do square roots of numbers that are not perfect squares. So we can do it. We are just not doing it today. Today we are just working on, I'll wait. Don't make me call out names on the video. Seriously, don't make me call out names on the video. So today we're just working with the perfect squares to give us that whole number for a square root. We can do square roots with numbers that are not perfect squares, but we don't get a whole number as an answer. We will find out how that works Monday. Today it's going to be easier. Matthew.
What, for like the 11th question, it says the square root of 36 121st.
Yeah, we're going to get to that. So that's good that you looked at that. And I'm going to show you what that means. So I have to erase the table so I can scroll up. Remember not to multiply the exponent by the base. When we have 3 squared, it does not mean 3 times 2. That exponent means how many times we're multiplying that base. So we've got 3 times 3, so that 2 tells me I'm multiplying that 3 2 times. 3 times 3. It is not 3 times 2. Okay, that exponent tells us how many times we're going to multiply out in expanded form. So if I had 3 to the 4th power, that would be 3 times 3 times 3 times 3. That exponent just tells us how many times we're multiplying that base number. Jude.
This year we're doing 1 cubed.
Yeah. Then taking when taking the square root, don't just divide by 2. Square root of 16 is not 8. Hello, Escape. She is with Nancy. That's okay. Bye. All right, Dominic, what did you want to add? Right. How did you know it was 4, Dominic? Because you know that 4 times 4 is 16. So the number times itself that got us 16 is the square root. So that's why we're working on those perfect squares. Thank you to my friends whose attention is up here. Olivia.
I remember, like, I think it was yesterday, I was talking to one of my friends, and they were like, turn the page, it looks like almost impossible, and I was like, it's probably going to be easier when, like, you learn it, and now it is. It makes a lot of sense.
Hello, the Escape. That's okay, bud. Okay, so yes, listening to explanations really makes things a lot simpler. So using the table above and the order of operations, evaluate the following expressions. So you have to know if you're squaring it, that would be 8 times 8. We're not going to give that as an answer because we want to evaluate. What does evaluate mean? What does the word evaluate mean in math class? What does it? Take apart. Do the math. What does it equal? So what is 8 squared equal? So I don't want to see 8 times 8. I want to know what is 8 times 8. It is 64. So you want to show that answer. Do you have to write it in expanded form? It does not say show your work. So you do not have to write it in expanded form. You can write what the answer is. Kaylin?
When you're finding the square root of 16, you can just divide 16 by 2 and 8 times 10.
I would prefer you not do that because when you get to the square root of 225, it doesn't work that way. So I want you to think what number times itself gets you 225. What number times 16, or sorry, what number times itself gets you 16. So you're doing it a more complicated way. That is not a rule. It doesn't work for every square root. So don't do it that way because it's going to confuse you. Okay. So it does say we need to use that order of operations. So that first row is easy, right? We're squaring, we're finding the square root, done, simple, easy peasy. But now down here, we have to remember that order of operations to find our answer. So first thing I do is exponents. 7 squared is 49. Next thing I'm going to do is my radical, because that exponents came before the radical. Square root of 16 is 4. Then I bring down the rest of my equation. 49 minus 4 is 45. So you have to think, what is the order of operations? The question that was before us was this one. What do you think we have to do? Emerson. So technically, you have that backwards. It would be 36 divided by 121. But do we divide first in the order of operations?
No.
What do we do first in the order of operations, Matthew? We do the square root. So what is the square root of 36? What is the square root of 121? 11. Then I simplify it if I can.
That's easy.
Yes. That's why we listen to explanations, because we go, oh, I get that now. That fraction bar means divide. 6 divided by 11 is not a whole number. It's not, we can leave it as our fraction. We don't have to simplify it. We don't have to do that division. You can leave it as a fraction.
Yay!
Matthew.
I said answer.
That is the answer, sir. It is numbers. 6 over 11 is numbers. And what did I say? Do we have to divide it? I said leave it as a fraction. Lucas.
So you know how you say you want to write squares?
Hold on 1 second, because I want us to get work time and then I want you to share with me. Okay? So you're going to do the math. Look at the bottom. Using an exponent in one and a radical in the other, write two expressions. One expression, oh my goodness. One expression with an exponent, one expression with a radical that equal the page number. What is our page number?
23.
What is the page number?
23.
So your answer has to equal 23. You have to do an expression. So it's not going to be a perfect square or square root because 23 doesn't fall in there. So you're going to have to do some kind of adding or multiplying or subtracting. You have to equal 23. One expression using an exponent. You can use as many operations as you need to. There is no limit put on this, but you must use an exponent. The second expression, you must use the radical. Any other operations to get your answer to equal 23. Okay? Kaylin.
Can we use a calculator?
You can use it to check your answer, but I want you using the table up top because that gives you all of this.
I don't think you even need to.
You can check it with your calculator.
Other than checking it.
So you can use it to check. With that, I'm going to say if you're watching this at home, I hope you are well. I hope to see you soon. Have a wonderful day.